All right, hopefully your quiz went well, and we're going to work on section 1.6. We're going to finish the notes. So you're going to want to make sure you have your book with you as we go over these notes. So the first thing, an exponential function, we've kind of talked about last week, but f of x equals b to the x. And the inverse of an exponential function is a log function. Log base b of x. Okay, so whatever the base was here, that is the base of the log. So those would be inverse functions. If you graph them, like if you graphed 5 to the x and log base 5 to the x, they would look like inverse functions. An example problem, let's just do this. Log base 10 of 0.001, and you could type that into your calculator if you want, is -3. And let's think of how we would write this with an exponent. You guys remember this implies 10 is the base to the -3 equals 0.001. So I guess there's one thing I want you guys to put above the example, and that would be log base b of x equals y implies that b to the y equals x. So this is kind of like the rule, and then this is an example of that rule. Okay, so the next thing we're going to do is go to Desmos. Could you actually, Jada, could you go to Desmos on my computer? You're going to run my computer for me. Okay, so we're going to look at Desmos real quick. You want to say hi? Say hi. Thanks for doing Desmos for me.
Delete that part.
Delete that part? Okay. I might not. All right. So what we have in here, and you guys could draw these two examples, is y equals to the x. You guys know what that looks like. That's the red graph that you see up there. And notice how it's an inverse with y equals log base 2 of x. Okay, Jada, in that third one, you just type in y equals x, and then you're going to see the symmetry line. Not cool? Nice. Okay, so then what you guys could do is sketch at home 10 to the x and log base 10 to the x. So you can do that on Desmos and sketch, and notice they are inverse functions. So Jada, if you'll delete the green and the red graph. Okay, and then what you can do to make this faster is if you hit that little gear thing, and then this copy, like the double, okay, and hit it again. I want you to have 4 total. Okay, but then change the 2 to a 5, a 10, and a 3. So what we're doing, this is the next example in your notes. We're comparing log base 2, log base 5, log base 10, and log base 3. Okay, and what do you notice? Which point do they all have in common? Yep, click on it. They all have the point 10 in common. And can you go back to the gear thing? And then click on this blue dot, the second blue dot. And why don't you change that to like red? And then change the next one to just make them all different colors, if you could. And then everybody can just kind of look at this and sketch down their pictures. So there's an example of different log bases, and they all contain the point 10. And why don't you guys write down what the domain and range is of all of those functions. Okay? So you go back to my flip chart, Jada. It's so nice having an assistant. Oh, my pen's not working. So just write down these 3 rules. Page 63. Write down those 3 rules, and we're not going to do the activity. If we were in class, we would do the activity. All right, the next thing we're going to talk about is natural logs. And same thing, we have log base e to the x equals natural log of x. And if you guys could write down these 4 rules about natural logs, and those are on page, they're not really numbered, but they're on page 64. Okay, thank you. Page 64. All right, next page. Okay, so now let's do an actual example. So if we know natural log of x equals 5, let's kind of think of what that means in rewriting. Natural log of x equals 5 means e to the 5th equals x. You can rewrite that. So remember, natural log and e, they kind of go hand in hand. So if we can solve this question, by if you take the natural log of each side, like this. So whatever you do to one side, you do to the other when you solve an equation. And what will happen is if you have a natural log and an e, they cancel each other out. You probably learned this in pre-calc, but just in case not, the natural log and the e cancel out and the exponent becomes the base. 5 minus 3x equals natural log of 10. And then now we would just kind of solve with the calculator. I'm going to try to get x by itself, so I'm going to subtract the 5. And then I'm going to divide by -3. And then you can type that in on a calculator. And what you will find is it won't be perfect. It's going to be a rounded number. So let's put a squiggly equal sign, 0.8991. That would be roughly what the solution is to that. So kind of take some time and look over that. You're not going to have to do any book work, but if you guys could have these notes done, that would be great. All right, next one. We're going to do another example. Okay, we're going to express this as a single log. First of all, I'm just going to kind of rewrite this. So natural log of A plus 1/2 natural log of B. Let's write that as a single log. So what we learned about is if you have a number in front of natural log, you can write that as an exponent. So natural log of A plus natural log of B to the 1/2 power. You could write it like that. And then remember, if you have addition, it really means multiplication. So we can write natural log one time, and we want to multiply A times B to the 1/2. And what's another way we could write B to the 1/2? Be A radical B. So either one of these answers are correct. I just think this one looks a little bit more simplified. So there's the end of 1.6b notes. And now I'm going to push pause and let me find 1.6c notes. All right, I recorded this on my active board earlier today, but then, I don't know, it was really hard to read. So I'm just going to do this one again with you guys really quick. So to prove that this is true, maybe it looks kind of scary or complicated, but all we're going to do is let's let y equal log base b of x. So think of like our notation about logs. So the base of b to the y, that's going to equal x. Okay, so again, we're trying to prove this is true. So, hey, we need some natural logs kind of thrown in. And remember, whatever you do to one side, you can do the other. So I'm just going to write natural log b to the y equals natural log of x. And then remember our exponent rule, just like with logs or natural logs, you can write the exponent out front. Y times log b equals natural log b equals natural log x. And you can probably see where this is going. Let's solve for y. Y equals natural log of x over natural log of b. So we have just proven log base b of x equals natural log of x over natural log of b. Okay, here are your, the end of the section 1.6 notes. So graph the growth of natural log and trig functions. So we're going to graph y equals e to the x, and that, remember, like anything to the 0 power is 1, so 0, 1, and then 1 is about 2.7-ish, and it's going to kind of look like it's an exponential function like that. The natural log of x, and you could plug some numbers into your calculator, but the natural log of 1 is 0, so you're going to have the 0.10 on this graph, and you could try plugging in some things here. But what you'll notice is that they are inverses. They're inverse functions. They reflect across the y equals x. So let me circle this. So let's take what we know about the natural log function, this purple function here, and then let's graph the natural log of x minus 2 and then minus 1. So this is going to move right 2, and this is going to move down 1. So if we take our graph from here, instead of starting at the 0.10, we are going to go right from that spot. We're going to go right 2, down 1. And if you think of like the asymptote now is going to also move 2 spaces to the right. and this asymptote, well, this will grow. Let's see. Kind of like that. Okay. Okay, inverse trig functions. So first, remember, trig functions are not one-to-one because they keep going on forever and ever and ever. Like if you think of the sine of x. So what we're going to do is we're just going to evaluate from negative pi over 2 to positive pi over 2, and then it would be one-to-one. Well, no, I should take that back. The trig, they're not one-to-one. We're going to restrict to negative pi over 2 to positive pi over 2. So the inverse sine, sometimes in a book, is going to be written like arc sine. I don't know if you guys remember learning that before. And what I want you guys to do is think about inverse sine is like what, sine of what leads to 1/2? Sine of what leads to 1/2? So we could like rewrite this as sine -1 of x equals y is the same as sine of y equaling x. Okay, so what values of the sine graph lead to 1/2 in this situation? So if the inverse sine is of 1/2 would be like, what value of sine leads to 1/2? So I like the right triangles when I think of sine cosine. Remember, sine is opposite over hypotenuse. So 1/2, 1, 2, radical 3. Do you guys remember these? So this would be 30 degrees, which is the same as pi, 30 degrees, which is the same as pi over 6. Okay, and then this is kind of a double. So let's deal with, all right, arc sine of 1/3. So 1/3 like this. So let's do the Pythagorean theorem. Okay, so 3 squared is 9 minus 1 squared is 8. So this would be radical 8, which is the same as 2 radical 2. So that's like the answer to this place right here. So if I want to take the tangent of this type of triangle, we're going to take the tangent of this triangle. So the tangent would be opposite over adjacent. So that would be 1 over 2 radical 2. And then if you don't like, you know, a radical in the denominator, you can deal with that. But that's just kind of to move things along. Let's kind of leave it there. Then I want you guys to look in your book at example 13, and they give you 2 different solution processes, and which one do you prefer? I like solution 2 better. I don't know, I just like thinking of, so this is the problem, cosine inverse tangent of x. And you can kind of just like read that over. So look at that in your book and then decide if you like solution 1 or solution 2 better. And I like solution 2. Whichever one you like better, write it down. Okay, like write down the solution in the book.